Alright, welcome back, and today we're going to look at listing 3.2. Okay, and I believe 3.2 talks about a decoder. And over here I have a simple 2-bit to 4-bit decoder, and it looks like it's active high. Yeah, so here's my 2 to 4 decoder. It has an enable pin, which will enable or disable it. Down here we have 2 control inputs, which is why we call it a 2 to 4, 2 control inputs. And then depending on the value of those control inputs, a respective output gets asserted. 2 bits down here gives you 4 possible values. Here's your 4 possible values. If this is 0, 0, then Y0 will be asserted. If this is 0, 1, Y1 will be asserted, and so forth. And here's your truth table. When enable is 0, the output is always 0. When enable is 1, then we look at our control inputs, 0, 0, and we assert the 0 line. When it's 0, 1, we assert the 1 line. When it's 1, 0, we assert the 2 line. And when it's 1, 1, which is 3, we assert the 3 line. So what we're going to do is use the conditional signal assignment statement, which we've just started talking about, to implement this decoder. Alright, so let's go ahead and do that. Here we have ISE Project Navigator. And what we're going to do is create a new project. Alright, so let's do our new project. And let's see, let's call this guy listing. And what do we want to call this? How about listing 3_02, alright? Because it's listing 3.2. And these are all my default values. We use the Spartan 3E and 500E, F flat grid 320. So we'll keep that. We're doing VHDL because you can do Verilog too, alright? Next, and then finish. Alright, so we've created our project. Same old thing. There's the listing 302. You look at this guy right here and make sure that's the right chip you're going to use. If it's not, you're going to run into problems. Now currently it's an empty view. There's nothing inside here. The view currently contains no files. Well, let's add our first file. Project, new source. Now what I want to do here is add a VHDL module because we're still learning basic VHDL. And I'm going to call this guy decoder. And this decoder is going to be 2 to 4. Alright, so we'll take VHDL module, we'll call it a decoder 2 to 4, and add this file. Now it's going to ask me for stuff. Now I could type it in, but you know, this is kind of neat. Actually, yeah, let's type it in here. If we go back and look at our picture, you know, what kind of inputs did we have? We have an enable input, and then we have a control input, 2 bits. We called it A1 and A0. And then we had 4 outputs called Y, 0 to 3. So let's go ahead and use this little wizard and implement that stuff. So I will put my A here. It's an input, yeah, and then it's a bus. And let's see, most significant bit, 1 down to 0, because we've got an A1, A0. Then I also have my enable. Okay, it's an input. Now it's not a bus, so I'm not going to check this box here. It's just one line. And then we've got our output, Y. Now that guy is an output. It is a bus, and we're going to call that guy 3 down to 0. Okay. Now that's going to stub out my entity for me. Okay. Gives me some information. A is a bus, 1 to 0, input. Enable is a input, 1 line. Y is a bus, output 3 to 0. Finish. Okay. Now let's go ahead and take out all the comments so we can kind of just focus on what we're doing. Now this line, this stuff right here you're going to need as you start doing arithmetic later on, but we'll go ahead and take it out now. And there you go. So that little wizard kind of stubbed out my entity block. Okay. The name of the entity is decoder 2 to 4. Port tells me my inputs and outputs. If I go back to my PDF file, enable's an input, A is an input, Y is an output. All right. And there you go. A is an input, standard logic vector. It's 2 bits, A1, A0. Enable is 1 bit, input. Y is an output, Y3 down to Y0. So there's the entity. Now what you have to do is actually do the implementation of this. So we're going to create an architecture here, and you could change the name, behavioral. You know what I'll do here is I'll change this guy and I'll say, well, let's see, we're going to use a conditional signal assignment statement. So let's call this conditional architecture, and then of course I got to change it down here because they have to match. So condition architecture. All right, they got to match. And now we have to actually do some architecture stuff. Well, the easiest way to do this, let's see, now we're going to do a conditional. Let's type what we're going to use. Conditional signal assignment statement. And if you remember in class, how did that work? Well, it basically said Y is equal to Well, what's y equal to? 1, 2, 3, 4. There's 4 of them there. y3 through y0. When, use the when, and then you have a condition when enable is equal to 0. All right, it's a single bit, so I use a single quote. Else, come down here and I do my next line. All right, so it'll be 001 when. Now I don't need to check enable because to get to this line right here, enable would have had to be 1. Okay, because if enable was 0, I'm going to execute the first line. But if I make it to the second line, then I know enable's 1, and at that point I can just check what the value of a is, which would be when a is 0, 0, that means it's assert y0, which is what I've got right there. And then same thing, we can assert y1 right there when a equals 0, 1. Else, and then come down to here and we can assert y2 when a equals 1, 2, 1, 0, which is 2. Else, and then we have our last one right here. We could just say 1, 0, 0, 0, and we're done. Yeah. So I could put a little comment here, and that is when a equals 1, 1. All right. So that's pretty much it. Yeah, that's one line, one single line, one conditional signal assignment statement implements the 2 to 4 decoder given this truth table right here. All right, that wasn't too bad. So let's save all this. Make sure we're in the simulation mode. Select our file. Open up in the processes window. Behavioral check syntax. Double click on that. And it looks like I typed it in correctly and it compiled. So we actually have the module now. The next thing to do is create a test bench file and simulate this guy. But things to note here is that enable is 1 bit, so I use single quotes here. A is a bus, 2 bits. Standard logic vector, I use double quotes there. Okay, I have to use an else clause, so when I come along here and I look at enable, and if enable is 0, I execute this line. If enable is 1, then I come down here and I execute all these. But they depend upon the value of a. When a is 0, 0, assert the y0. When a is 0, 1, assert y1. When a is 1, 0, assert y2. And then the last possibility on a would be 1, 1, and I can just have an else keyword and then one line down here that says y takes on the value of 1, 0, 0, 0. So y basically can take on any of these 5 values depending upon enable and a. Alright, okay, I think I'm going to stop here, and in the next video we'll create a test bench file to simulate this. Okay, thanks for watching.